All right, hello again, guys. This is going to be the last video for chapter 10. Um, this section in your chapter is going to address the last two learning objectives, 11 and 12, for chapter 10. And we're going to talk about identifying the statistical techniques um, that you would use for all of the non-experimental, quasi-experimental, and developmental designs that we discussed in this chapter, and the strengths and weaknesses of those, and how the terms are used in research, specifically quasi-independent variable and dependent variable, which we will talk about in just a minute. So basically, this is going to be a pretty short video because honestly, the application and analysis of the between subjects designs that we discussed here, the non-equivalent control group and the cross-sectional designs, those are very similar. The pattern of how you apply and analyze is very similar to how we discussed the between subject experimental designs in chapter 8. And then the within subjects non-experimental designs we talked about, which is the pre-post and the longitudinal designs, those are very similar. The pattern is very similar to how you would apply and analyze as the within subjects experimental designs that we discussed in chapter 9 at the end of both of those chapters. So this is very similar information that is going to sound very familiar to you guys. So let's get this application and analysis thought up. Okay, so again, two group designs, as always, is the simplest design where there's just two groups, right? No more than two groups. It has the advantage of being the most simple. It is easier to set up. It is easier to understand the results and interpret the results. So that's the advantage there. But again, just like the other designs that we talked about, when you have only two groups, it does not necessarily provide the full picture, the full functional relationship between the independent or quasi-independent variable and the dependent variables. When you have multiple groups, remember that can reveal a bigger picture or more information. And so, but again, that does make it more complicated. And so it just depends on what you're studying as far as which choice you go with. For two groups, the design analysis, you are comparing, if you're comparing numerical scores, it's going to be with a t-test, if there's two means, or a single factor analysis of variance, or ANOVA, so a single factor ANOVA. Again, single factor because there's only one independent variable for multiple means. So if there's more than two, you would use the, more than two conditions or groups, you would use the ANOVA, and the t-test is for two. And this would be either independent t-test or independent ANOVA, or repeated measures t-test or repeated measures ANOVA, depending on whether it was between subjects or within subjects. Remember, if it's between subjects, it's an independent t-test or an independent ANOVA. If it is a within subjects design, it is a repeated measures ANOVA or a repeated measures t-test. And again, if you are repeatedly measuring the participants, the same participants, obviously repeated measures is the test you're going to go with, right? It's in the title. If it's not numerical scores that you're analyzing, you would use the chi-square test again for non-numerical data. The tests for all of these are discussed more in chapter 15 again, for those of you who are wondering if we're ever going to talk about that. Okay, and then now, so that addresses the majority of the non-experimental and quasi-experimental and developmental designs that we talked about. But there also is this pre-test, post-test, non-equivalent control group design we talked about, which is where there's a within subjects component and a between subjects component. The pre-post-test is the within subjects component, and the non-equivalent control group is the between subjects component. So when you're talking about that, The statistical analysis that you have to use for numerical scores is a two-factor mixed design, ANOVA. That doesn't necessarily mean anything to you right now, but what that means in basic terms is that two-factor, again, because it's going to require more than one independent variable to be analyzed. And then mixed design means that it is an independent as well as repeated measures design. And so ANOVA is the only kind that can handle that complicated setup, that complicated design of analysis. And so there would be statistical software programs that would be the best for doing that, because that is a lot of math, like SPSS or JASP that you guys have been studying. So that is that. And then the terminology we need to discuss, you've heard me use it a couple times. I hadn't used that up to this point because I didn't want to confuse you guys. But really, a lot of times I've been saying independent variable in this chapter. I've been saying I'm putting air quotes around it, even though you can't see my fingers, because it isn't a true independent variable because you're not manipulating it. So when it's non-experimental or quasi-experimental, there's not true manipulation happening. And so it is not a true independent variable. So what it is called in this context is a quasi-independent variable, because it is sort of an independent variable. That's the variable that you are looking at, at possibly influencing your dependent variable. And again, dependent variable is the same. That's what you're measuring. That's the scores you're getting. But again, because it is not being truly manipulated, it has to be considered a quasi-independent variable. And that just helps distinguish it when you're reading about someone's research, so that you know exactly what they were studying and how they were studying it. So real quick, let's do the learning check for this section. So what is the appropriate statistical analysis for comparing non-numerical data for a differential design comparing samples representing two populations? Honestly, the only word that you need to, or the only phrase you need to look at here is non-numerical. As soon as you see non-numerical, you should have known that it's going to be the chi-square test for independence. Chi-square is what is used for non-numerical scores or non-numerical data. Number two is, what is the appropriate statistical analysis for evaluating the after-treatment mean difference for a post-test only non-equivalent control group design? Now, I know that is a lot of words. So again, I'm going to tell you what the key thing to look for here is the non-equivalent control group design. If it is non-equivalent control group, then that is a between subjects design, right? And so if it's between subjects, remember that is considered an independent, between subjects, independent. When you hear those two terms, those go together. So it's an independent measures t-test. The other answers here are not correct, because repeated measures would be a within subjects design. That would be a pre-post design, or a longitudinal design, or something that requires you measuring them more than once. This is a post-test only non-equivalent control group, so it is not repeated measures. And then, of course, we just talked about chi-square is for non-numerical data, and this is talking about a mean difference. So obviously, if there's a mean, if there's an average, then there's numbers, so it is not a chi-square. And then lastly, in a differential research design, what term is used to identify, that's a typo, to identify the participant variable that is used to define the groups? So remember, in differential, we're just looking for a difference between groups. And if it's a participant variable, then it is not being truly manipulated. And remember, differential is not a true experimental design. It is non-experimental. So if it is not truly being manipulated, if a participant variable is the thing that is that is already part of the participant, like age, gender, etc., and it's not truly being manipulated, and you know that goes along with differential research design, because again, that's non-experimental, then it would have to be a quasi-independent design. quasi-independent variable. Sorry. Again, if it was an experimental design, you could say independent, but it is quasi-independent. The reason it's not dependent is because you're talking about the participant variable for one, and also because it's being used to define the groups, right? Whatever is using to define the groups, that's your independent variable. The scores that you're measuring, that's your dependent variable. And then quasi-dependent isn't even a thing. Obviously, we said you call it your dependent variable regardless. Whatever you're measuring is always your dependent variable. So that is it for chapter 10. We are at the end here for our self-assessment here for non-equivalent group designs, pre-post designs, and developmental designs. That's all the things we talked about in this chapter. We talked about a lot. It's a lot of information. So here's 4 questions to kind of get you thinking about all the things we talked about. What is the distinction between experimental and non-experimental research? Remember, the main thing is that a non-experimental cannot satisfy all the rigorous requirements of an experiment. Most often, that is the manipulation of the independent variable or the controlling of the extraneous variables that become confounds or threats to internal validity. And when you can't do those things, it becomes non-experimental. Why we can be more confident about, I think it's supposed to be why can we be more confident about causal relationships between variables when a quasi-experimental design is used instead of non-experimental. Remember that quasi-experimental, the reason it is quasi-experimental is because it takes a step that the non-experimental does not take, which is to attempt to control those threats to internal validity we just talked about. And when steps are taken to do that, it is then usually considered quasi-experimental instead of non-experimental. And then how does the pretest help minimize the threat to internal validity from individual differences in a pretest, post-test, non-equivalent control group design? Again, remember, the pretest is introduced so that you can compare the groups ahead of time to see if there are already differences that exist, individual differences that exist before the treatment, or before your independent variable, your quasi-independent variable is introduced. And so if there are differences that exist in the pretest phase, then you know that there is some variables there that are potential confounds, that are potential threats to internal validity. If they are similar on that variable ahead of time, on your dependent variable ahead of time in the pretest phase, then you know that if they are different in the post-test phase, then it is likely due to the treatment or the quasi-independent variable. It is not due to those individual differences. Well, but you can feel confident that it probably isn't. And so that is why it is helping minimize those threats to internal validity. And then lastly, why can the cohort effect be a serious problem for cross-sectional research, but not for longitudinal designs? So for the, remember, the cross-sectional is that snapshot, which is, great for simplicity, for time, and all of that. But because you're taking, you're getting information, you're measuring, you're getting scores from different ages at the same time that grew up in different eras, that had different history, that experienced different times in our world and our culture. There could be differences there in their cohorts that can be a problem for interpreting your results, because maybe the differences on the dependent variable had nothing to do with age and had more to do with their cohort and how they grew up, and the things they experienced in their generation. But for longitudinal designs, remember, you're looking at the same people as they grow, and so you don't have to worry about that. There are no cohorts or generations there. It's the same people as they grow. So hopefully that helps you remember all of that. And so here's your summary, which again, remember, is just your 12 chapter objectives from this chapter. Here are 6 on this slide. I don't know why that highlighted that. And then there's the other 6 on this side. And so remember, now you should be able to you should be able to understand all of these things and know what they're talking about. And if you have any questions about any of this when you go through it, you can always let me know. Make sure you read the actual chapter summary at the end of your chapter. That always helps wrap up things really nicely. Your textbook does a great job of that. There's also key terms and keywords you can look at. And of course, the learning checks and your quizzes will help you to make sure that you have all of this information really nailed down in your brain, especially for making sure you're understanding it, but also preparing you for um, midterm and final exams. So if you guys have any questions, as always, I'm here.